Hello everyone, my name is Tom Cherry Holmes, and this is another video on the Retro Computing Archaeology series. I wanted to do something a bit interesting, something that's very close to my heart, and something based on a series of observations that I first had when I saw the Amiga. For me, and for my father, who also saw the machine in its very early stages in 1985 and 1986, saw the machine not so much as a souped up game machine, like a Commodore 64 with jetpacks, but we saw it as a low-cost workstation, a low-cost color workstation. I don't know quite how these videos are going to pan out, but I'm doing them very organically because I'm trying to make a very specific case, one that the Amiga made an excellent engineering and scientific workstation, something that a lot of people didn't use their Amigas for, but it was something that the Amiga was very well suited towards, precisely because of its more creative aspects. It had a number of other wonderful attributes as well, such as its price, especially when you consider that in 1986, the typical scientific workstation was something like a Sun 2120, a 68,010-based machine in its monochrome display configuration, which would cost more than $27,000 for a machine with approximately 2 megabytes of RAM and an 1152 by 900 display running a copy of Unix called Sun OS. At the time, version 3.0 had just been released. By contrast, the Amiga itself, with its monitor, was approximately $1,795 retail. And so, with that $1,795, what did you get? Well, in order to take and actually demonstrate this, I'm actually going to be using my desktop here. And I'm going to be using a copy of WinUAE, which is an excellent emulator. Since I am running it on Linux, I am running it under Wine, but it runs quite well under Wine. And I'm using emulation rather than real hardware for a variety of reasons, but the most important is the ability to dynamically specify exact configurations of a machine that I want to demonstrate. This is perhaps the best plus for using emulation for videos like this. And to that effect, we're basically going to be showing an Amiga 1000, like the machine over here on the lower right-hand corner, with 512K of chip RAM, meaning it has the memory expansion in the front. We have 2 disk drives, which I'll go ahead and enable the second disk drive, because we will have an external disk drive here as well. We'll need it later for later videos, but I'll go ahead and enable it here. And it will be an NTSC machine. As a matter of fact, let me go ahead and run a pre-configured configuration here, which will have everything we need set up. Everything is cycle exact, NTSC machine, and we have the original Amiga 1000 bootstrap ROM with the writable control store. In the earliest days of the Amiga, the operating system hadn't been finished yet, and so the operating system was distributed on floppy disks. The floppy disks containing the actual ROM operating system loaded into the writable control store was called a kickstart disk. And at this particular point in time, let's say the spring of 1986, 1.2 had not been released yet, so we'll be using a version called 1.1. Very few actual machines that were released at this particular time had the 1.0 kickstart, and it was very quickly superseded as 1.1 came out in November of 1985 and was shipped with the majority of the machines that went out. We'll go ahead and start the machine here. And the first thing that we have to do I've already inserted the Kickstart disk into memory. There's a little startup chime that you don't hear, but it comes up nonetheless. And the Kickstart disk is then loaded into memory. It takes up 23 tracks on the disk. Once it's done, the system reboots into the new operating system that has been loaded into the writable control store, and the writable control store is subsequently write protected. At which point we can insert the Workbench disk, and we'll start to see what we were presented with once we had loaded our Kickstart and Workbench disks onto a system. Immediately we're presented with the graphical user interface of the system, which R.J. Michael called Intuition. A name so chosen because it was intended to make the Amiga easier to program, abstracting a whole bunch of graphical and input and output functions. But its primary use was to provide the user interface for the system. We see a mouse here, which is being run by which is implemented as a sprite. We see icons, which are drawn onto the backdrop of the display here. And if we click on a disk, we see that we now have the contents of the disk actually open on the screen here. And if you had used a Macintosh up to this point, you might be forgiven to think, okay, well, great, it's a color Macintosh. But this is kind of where the similarities end. For one thing, you may notice that we've got some demonstration programs here. And these were the demonstration programs that were shipped with the first two versions of Workbench, 1.0 and 1.1. They're simple demonstrations that were written in C, compiled with Lattice, to show the graphical features of the machine. We have one window drawing dots here. We open up another window. We have a window drawing boxes, but the dots window hasn't stopped. We open up another window here, and we can see almost immediately that these three programs are running concurrently with each other. They're multitasking. And you can see that even with this, the 68,000 here is not really pushing all that much. In fact, you can look at the bottom of the screen here where the CPU meter is actually active, and you'll see that the 68,000 is mostly idle. This was something that was brought up at the Amiga launch event, and for those of us who actually who saw videotapes of it much later, were very surprised by this. But it was possible because of the extreme integration with the underlying hardware here. Here we had a machine that had a very sophisticated operating system with an equally sophisticated user interface, with complex methods for handling things that were very hairy and still very new concepts at the time, things like backing stores, handling color graphics, handling tiled windows, which was still very problematic and something that Microsoft Windows wouldn't get until version 2.0 of its software, and so on. So it was very, it was an incredible eye-opener here. You have windows going behind other windows, and the programs are just sitting here running, doing their thing. And you immediately realize, yes, this is a powerful multitasking machine with extreme color graphic capabilities. But it didn't end there. Some of us actually got an additional disk. If we asked the dealer nice enough, these were demos that were running on the dealer's machine. I'm actually going to take and put this in the second drive that I have allocated here, called the Workbench demos. This particular one is dated the 25th of November, 1985, so it needs Workbench 1.1. And when we put it in, The system automatically notices that the change in disk, mounts the disk, puts it on the desktop so we can use it. And we have a handful of different drawers here, which is what they call directories on this machine, for different things. All sorts of interesting things start to happen here. We'll start with the animations here, particularly because the animations folder contains what is quite possibly the most notorious demo of them all, the Boing Demo. We'll go ahead and launch it. You'll see that the display has gone through and changed. And the one thing you'll notice is that the mouse pointer has also changed here too. The dealer would quietly tell you that you would need to change your window ordering, and you could then see the Boing Demo on display. And you can see the demo working in all its glory with sound. An impressive feat for 1984, let alone 1986. And using a variety, basically using a whole bunch of the Amiga's graphics tricks to actually render the ball on screen. I'm going to turn down the speakers here so we don't get bothered by the bounce. And the rotation of the ball itself being handled by color palette cycling. We're looking at a 32 color palette display here, and each of the 32 colors in the palette, a subset of them, are being cycled through in a specific way in sequence to simulate the rotation of the ball. The big ball itself is in and of itself a particular pair of bit planes here, and the position of the ball is literally done by changing the position of where the graphics chips are reading those particular bit planes from memory. Since this is a pointer operation, this happens very quickly. And this is happening while the CPU is, in reality, doing very little here. Again, notice the display here. There are all sorts of other tricks also in play because the bit planes are being manipulated to make it appear that the background is actually sticking in place when it actually isn't. But if we now take and move backward here, some things actually happen. In fact, I will restart this demo and we can see some of the effects actually happening. You can see the color palette changing, everything being shifted. We'll take and start it again. But this time, I'm going to take and do this in a very specific way because I want to demonstrate that the multitasking really is multitasking, even with full screen applications, quote unquote, full screen applications. Because Intuition actually provided, among other things, the ability to have viewports onto which screens of different resolutions, things mixed around, could be separated vertically. And the entire screen-by-screen system present in Intuition was built around this. So we can see even here, with the Boing Demo loaded in back, we can see that we can still multitask with the existing system here. And it is happily moving along, only interrupting in spurts when it needs to for critical operations. A truly fully multitasking, a full multitasking machine. We'll take and close that off, get the memory back. And there were others too. One of the more compelling demonstrations also was RoboCity. And RoboCity, even though it may look like a simple 2D animation, there's a lot going on with RoboCity. RoboCity is using the animation features, a complete multiplanar animation system in ROM, to move the movable objects on the screen. And not only to move the movable objects on screen, but to also perform collision checks and other things. You'll notice that you have tasks sending messages back and forth between each other, such as when the dog gets close to the fire hydrant reacts, and so on. And all of these things are implemented as mixtures of playfield graphics, glitter objects, and virtual sprites, all under control of the operating system here in a very cross-platform way. It's one of the powerful aspects of the system, and this is built right into the operating system ROM. We can go ahead again, just as before. We move down, we can take and close the application and move on. Amiga 3D was also good here too, but I won't go into it as that particular version has some bugs. It's a three-dimensional rotation thing. I want to take a little bit of time here to go into the graphics displays, because the graphics displays are where we start to also see some of the more advanced aspects of just individual graphics modes, as well as, in the case of fields, the fact that the Amiga has hardware-assisted Bresenham line draw functions in the hardware. And it really makes for extremely high-performance area fills, line draws, etc. The area fill also uses the line draw, by the way. It's very fast. And it makes things really high performant. Come back here for a moment. Sure, why not? Oop. Apologies, didn't mean to do that. Looks like I'm going to have to recover my Workbench disk slightly because I made a little boo-boo because there were bugs in the early version of Workbench. But it becomes very apparent here that there was a lot of forethought put into all of the various graphic functions in the graphics library to make a high-performance visualization workstation that quite honestly kicked the pants off of just about anything else that was around, especially in the personal computing sector, for quite some time. We'll go ahead, move this away, boom, fine. Goodbye. Pull the fields. And we can see the high color mode that's present on every Amiga, the hold and modify mode, which basically functioned by providing a 6-bit plane mode, by which the first 4-bit planes would specify a base color. And then you could use the last 2-bit planes to modify a particular color component being a red, green, or blue set of each of these base colors to produce complex shading effects. And you could see here, even with this basic demo here, that it was easy enough to take and use the routines in the Amiga to take and draw charts. And this one was specifically done using one of the 3 backing store methods. This is a simple window. This means that the window is redrawn. And in the case of this particular program, it's redrawn every single time that you move it or change it. And it was specifically done to show the speed of how fast the Amiga could actually take and update the window, even if it's changed. Finally, we'll also see that we have the colorful demo here, which gives another aspect of the hold and modify modes here. So if you were willing to take and sacrifice a bit of resolution for certain still displays, you could actually gain quite a bit of color fidelity. So the final bit that I'm actually going to take and cover here too as well, that's not immediately evident, we'll actually go into the graphics folder. And oh, sorry, not the graphics folder, but the pictures folder. And we'll see a variety of different pictures that we can open up, and it will open up a program which has these images embedded and open up a window here, and you can see the Amiga's bitmap graphics capability. Now you may be asking, why on earth were these programs built like this, where you have a window here in the back and you have this other window here in front with essentially the same image? This is here to basically demonstrate two major things. One, that the intuition itself was built on the concept of graphics layers, which were implemented in the layers library, and that the layers library does all of the hard work for implementing any backing store requirements for these windows so that they can be restored whenever they're partially occluded and then re-exposed again. But you'll notice that this is happening actually very fast. In fact, most of the time that's being spent here is actually being spent using the blitter to take and move the window from one section to another here. And you'll notice that the updates back behind are pretty much instantaneous, also facilitated by the blitter. But something that may not be immediately evident with this is that these particular pictures, in fact, these two windows that are actually put up for each individual image, are actually the result of being pulled from precisely the same backing store. These two windows use a mode called Superbitmap, which means for this window, for the contents of this window, I want to take and pull my contents from a specific location in memory, so that anytime the contents of that memory are changed, they are automatically reflected in the windows, as well as handled by any window exposure or occlusions that may occur. And because of that, updating these windows is extremely fast. It's just, you're just doing pointer fetches. And these pointer fetches are happening, again, with the 68,000 not needing that much CPU time at all. Very powerful concept. So if you have a particular buffer that you're updating back in the back in memory somehow, say you're algorithmically generating an image, you can literally just have the Windows system pull from it, and it not needing to do any copies whatsoever in order to put the contents of that window up on the screen. Just manipulating only in certain cases that would you need to do a full copy here. And even in those situations where you actually have to do a full copy of the Windows contents, the blitter can do that extremely quickly. So even with all this, you realize very quickly, even with the basic demos that are in place here, that this machine, and for those of us who were looking at this machine in terms of a graphics visualization workstation for scientific or engineering use, it became very evident that this was an excellent low-cost option that, quite frankly, beat the pants off of the bigger workstations, even though the bigger workstations would have more storage, faster processors, perhaps, say a 68,010 or a 68,020, and more resolution, most definitely. Part of the point of these videos here is to take and compare these workstations using emulation environments similar to what I have here, to ultimately make the point that in a very general sense, the Amiga was a very compelling graphics workstation. I don't know how long it will take me to take and create these videos, but I hope I can get all the pieces together to do it. And I would really enjoy it if you guys came along with me on this journey here to actually look at all of these different systems, to compare them with each other, and to get an accurate historical context, as accurate as we possibly can get given every circumstance, to show that, and for me to actively validate the case that the Amiga is a very capable scientific workstation. And at the time, that was especially so. So with that, thank you guys very much for watching. I hope to see you on the next video.